So in this use case, we'll discuss about in general how if we have a data center which is connected to a WAN. Let's say that's this WAN is what we will have the SR-MPLS, right? And then it's connected to it's providing the internet to this data center. So let's talk about data center first. So data center, the first thing is the control plane. So if we talk about control plane, so what in data center that we are using EVPN, right? When we are talking about the data plane in data centers these days, well known is what VXLAN, right? So in terms of when we are connecting this one with, let's say we are connected this to a WAN and the WAN is MPLS. So this WAN provider interconnects with each other. Even this is a DC kind of DCI setup as well with a different data center or providing internet. In WAN, basically we will use SR-MPLS or RSVP or LDP, right? So what are the pros for this setups? Means using this control plane as EVPN and data plane as VXLAN, SR-MPLS, right? So if we discuss about the pros, so pros are basically VXLAN and EVPN-VXLAN stack is been supported and adopted by everyone these days, right? So second thing is like EVPN can provide different services, like we will say that L2 services, L3 services, everything. Similarly, pros, for example, will have MPLS, and based on MPLS will have segment routing or RSVP, which will be used for in terms of very much mature protocol. It is supported by multi-vendor and multi-vendor. Also, it can give you the traffic engineering capability as well, right? This is what the pros that we will have. So when we are talking about the, for example, what are the cons for these when we are using VXLAN, right? So when we talk about cons for VXLAN, so VXLAN, one of the major cons is that it do not provide any kind of traffic engineering. There is no traffic engineering capability in the data center if you are using VXLAN. Another thing is whenever we are talking about any kind of service chain functions, right? So whenever a service chain function we are talking about, VXLAN can provide those service chain functions, but it required policy-based routing or a default gateway, or it need, for example, VLAN handoff to do the service chain function, right? For the data center perspective. Also, whenever we are talking about VXLAN, then, for example, in order to create the, underlay, we need to have the loopback address, and that loopback address should be IPv4. There is no IPv6. SR-MPLS is not yet widely used in terms of the DC optimization. So a DC optimization, basically in the DC domain, data center world, we do not use SR-MPLS. Also, we need to do what? Stitching. So we need to have a device which will be capable of one side to be as VXLAN and another side to be addressed as MPLS. So stitching, this device should support both the encapsulation mechanism. One is VXLAN, another one is MPLS. So think about, this is a SR-MPLS, this is EVPN-VXLAN, and we have this scenario. We discuss about the pros and cons for each what we are using it here, but when we are talking of when we will use SRv6, so SRv6 can support everything, right? So address all of these issues, right? So what is that? So SRv6 will address all of them. So basically, first thing is it will bridge between the data center and the WAN together. How? It will create a unified data plane in which it is purely based on IPv6 and IPv6 here, and it will do a routing end to end. Suppose, for example, here I have a application somewhere from here, there is a customer is there and wants to communicate with the application from here. So end to end IPv6 connectivity. So there is no requirement of stitching point in the DCI. So same, and there is no different thing, like though there is no different encapsulation, only end to end we can have IPv6, right? If you want to do any kind of traffic engineering perspective, with SRv6, we will also have a traffic engineering capability provided in the data center. For example, let's say we want to do a service chain function, right? How the service chain function will be addressed here. So for example, we will have a firewall here, and also we will have something called as DPI to be placed over here. So any packet which is coming from the external should go to the firewall, and based on this firewall, it will take the decision and then deliver it to the respective application. Or else, also, if there is any traffic which is coming, it should go to the deep packet inspection to check what is the content of the packet, and then it will deliver. Or for example, or an application is sending anything towards, so deep packet inspection has been done, and then it will send. So service chaining function is by default enabled in terms of SRv6. We'll discuss this how it is being performed. So this is also possible here. Well, another major thing is, for example, we want to have a end-to-end L3 services from a DC all the way to, for example, this somewhere there is a PE over here, and then we want to establish an L3 VPN setup for this, right? How we can do that? We only need to only need to enable SRv6 in this device and in this device. If rest all devices are only IPv6 capable and they are able to deliver, like they are able to do the routing based on the destination IPv6 address, that's enough. SRv6 enabled on the PE and in the leaf will enough to cater the end-to-end layer 3 VPN setup. This will advertise the locator. So we'll discuss about locator in our further modules. So this will advertise the locator, also the VPN function. Based on the VPN function, which VRF it will be the part of. Similarly, here also same thing. It will advertise the locator, and based on this locator or based on the VRF, what is the function is being advertised. Remaining all the transit devices only do the IPv6 routing. They only do IPv6 routing. End nodes will do the lookup for this locator. Based on this locator, it will send it towards the based on the function VPN function, whatever it is push it towards the VRF, and then further communication will possible. So this is another example in which we can say that SRv6 will be beneficial in order to have, rather than having a multi-protocol environment like VXLAN over here, MPLS over here, we need a stitching point over here, right? So if we use SRv6, so end to end, we can have only one protocol, and then we can achieve this.